Hope everyone was here. Too bad. Okay. Let's see. Cool. Okay, cool. So that was a non-metal, so hopefully that should be, it should be nice that we categorize these. The last case we had was hydrogen plus compounds. And we saw that these could be acids if aqueous. All right, and remember we had kind of three special rules for dealing with hydrogen ion containing compounds. We saw that we could have, for example, plus something. You know what? Let me move these over to the side a little bit, just because we have a little bit more room. If we have this plus something with "ide," the name of that becomes hydro blank ic acid. Oops. Okay, so remember that whatever is here goes here. So whatever is in that place. So for example, chloride or bromide. Elsa, yeah, how far would you like me to go up? Like it's here good for now? You know what? My sound is off. That's why I can't hear you guys. Okay. S2O4. Okay, so can you see the S2O4 part then? Okay, cool. I'll just leave it here for a couple seconds and then we'll move back down. And as always, I'll post these up in the lecture note area for you guys to see. Okie doke. So back down we go. So remember for our hydrogen compounds, we're going to have special names, right? So we also had, what if it were H plus something ite? Then that became blank acid, right? And then the last case, we had H plus something with 8, and that became rather, ic acid. All right, so hopefully this this kind of summary thing will help you guys out. So I will of course upload this, so hopefully this will be nice and organized so you guys can see kind of the formulas of how to get these names. Okay, so let's just do a couple of practice problems. I know that you guys have 140 for homework plus a whole bunch for the lab. You guys are going to be completely sick of naming stuff, but you will know how by the end of all of this. So let's just do a couple practice problems. How about we do, I'm going to do all sorts of stuff, okay? So we're going to have mixed stuff. Okay, how about we do that one? And how about that one? And how about that one? And how about and phosphorus Whoops. Okay, have fun. So we're going to go ahead and, oh my goodness, I'm so sorry. We're going to go ahead and tackle these 5 problems. And go ahead and type in your answers to the general discussion once you guys are good with them. In the meantime, I'm going to check out our poll, see if we have any. Okay, still same. Cool. Aha! Elsa, I tricked you. Why is that not right? Yeah. So remember, we're not going to use di, tri, etc. with metal nonmetals. Only with non-metal nonmetal. Okay, that's fine, Sarkis, I can do that. Very good. Very good. Yeah, I can explain the third one. But let's go ahead. Let me get the answers for the last 2, and then we can explain all of them. Okay? I like that. This should be. It's actually going to be H3, right? Indeed. Selenium is number 34 on the periodic table, in case any of you are wondering. Yes, Cassidy. In order for us to name something as an acid, the formula needs to be aqueous. Yep, you're right, Melissa. All right, yep. Se2, S2. Very nice. Okay, so we saw that someone did fall for my trick and say difluoride. Why was that not correct? Exactly. So because calcium is a metal and fluorine is a nonmetal, we are not going to ever need to use the di, tri, tetra, whatever, all that stuff. It's just redundant, and we just don't do it as a result. So yeah, we're only going to use it if both components are nonmetals. Okay? With regards to the third one, well, does anybody have any questions on any others? I know Robert wanted to go over the third one, sodium hydride. So we can do that. And if you guys have any other questions on these ones, go ahead and type them out. But in the meantime, we'll take a look at that. So, Robert, what kind of compound is this? As in, is this an ionic compound or a molecular compound or an acid? Sure, Josh, we'll do that. It's metal, nonmetal, exactly. And that tells us that we're going to have ions involved. And so we remember sodium has to be what charge? Yeah, sodium must always be +1, right? So that tells us that hydrogen is what charge? Yeah, Robert. Unfortunately, two positives are not going to come together here. So hydrogen in this case is -1. So remember, hydrogen could go either way. Remember, depends on what it's mixed with. Okay. I'm waiting. Yeah. Oh, what the heck is TT? Okay. In any case, if anyone else had any other question related to this one, so we would name this as sodium. And remember, this is hydrogen, right? But when we have it in a metal-non-metal compound, we have to kind of take off that last bit and call it "ide." So it'll be sodium hydride. There's no such element as TT. Fine, here. There, now it's pretty. Oh, and I've ruined it. Okay. There. Okay. Though technically, I'll get out of here, Robert. It couldn't be TT, and let me tell you why. Not only is TT not on the periodic table, but remember, elements have to start with a capital letter. So if it were going to be TT, it would be NATT or something like that. It would have to be, one uppercase, one lowercase. So that's why. Yeah, cool. Okay. Hydrogen is a nonmetal, yes. Because if you think about the typical metals we have, they're hard, shiny, silvery colored, bendable, all that stuff. But hydrogen is a gas, right? Hydrogen does not have the properties of conducting electricity and all that stuff. So, yeah, definitely hydrogen is a nonmetal. Okay, that's just kind of where they stuck it on the periodic table because it has that one valence electron, but it is definitely a nonmetal. Okay, so if we look at the phosphorus acid example, all right, so when we're given the name, we kind of want to look at what the last bits are. So we see that this thing ends with us acid, and so we know from going back to our chart that if something has us acid, it had come from ite beforehand. Yeah. So that tells us this should have been ite, right? And technically, yes, there's no such thing as phosphorite, but we do have an ite that's very similar, right? Phosphorus and sulfur are kind of exceptions. We say sulfuric acid instead of sulfic acid. I'm not sure why, but yeah. Hopefully that's not too much of a stretch to go from phosphorus acid to phosphite. So this one must have come from phosphite, right? And so now we'll need to remember that phosphite is PO3 3-. And so if we wanted to make a compound between H plus and phosphite, If we wanted to do our crisscross, this number goes here.